Selamat datang di Fakultas Pertanian Universitas Brawijaya. Fakultas ini memiliki 4 jurusan, yaitu jurusan Tanah. Bidang kajian di jurusan Tanah memfokuskan kelestarian lingkungan menuju terciptanya sistem pertanian yang berlanjut, manajemen kesuburan tanah dan ketersediaan sumber daya air bagi tanaman, serta manajemen sumber daya alam termasuk agroforestry dengan pendekatan ekologi ekonomi yang seimbang. Jurusan Budidaya Pertanian. Jurusan Budidaya Pertanian mempelajari dan menerapkan cara-cara peningkatan produksi tanaman serta perbaikan teknik budidaya tanaman secara berkelanjutan. Aspek yang dikaji yaitu genetik tanaman, fisiologi tanaman, penampilan fisik tanaman, dan kondisi iklim mikro dan makro di sekitar lingkungan tanaman. Jurusan Hama dan Penyakit Tumbuhan. Arah pengembangan keilmuan di jurusan HPT yaitu mengkombinasikan IPM, ICM, dan ISM untuk mewujudkan sistem pertanian berlanjut. Selain itu, jurusan Hama dan Penyakit Tumbuhan juga mendukung program nasional Go Organik untuk menghasilkan produk pertanian sehat yang bebas bahan kimia sintetik berbahaya. Jurusan Sosial Ekonomi. Fokus bidang ilmunya yaitu analisa perkembangan ekonomi pertanian nasional dan dunia literasi keuangan, pemasaran, dan analisa perilaku konsumen. Interaksi sosial dengan masyarakat pedesaan serta komunikasi efektif dengan pelaku agribisnis untuk mengembangkan pertanian yang berkelanjutan. Serta pasca sarjana. Kurikulum di pasca sarjana didesain khusus dengan kombinasi keilmuan berbasis kompetensi teori maupun terapan, sehingga sangat sesuai dengan kebutuhan para akademisi maupun para praktisi di sektor publik dan bisnis. Sejak didirikan pada tahun 1960, saat ini Fakultas Pertanian memiliki 11 program studi dengan sebagian besar terakreditasi A oleh BAN PT dan program studi di sarjana yang telah tersertifikasi AUN-KIA. Fakultas Pertanian Universitas Brawijaya memiliki 15 pusat kajian, 2 jurnal terindeks Scopus, 20 laboratorium keilmuan, 3 laboratorium lapang. Hutan pendidikan UB Forest seluas 554 hektar, Agroteknopark Kebun Jati Kerto untuk teknologi budidaya komoditas pertanian dataran rendah, Agroteknopark Kebun Janggar untuk teknologi budidaya komoditas dataran tinggi, Kebun Percobaan Jatimulyo untuk kegiatan urban farming, serta memiliki ruang kelas untuk proses pembelajaran. Fakultas Pertanian bertujuan untuk menghasilkan lulusan pertanian yang profesional, kompeten, beretika, serta memiliki etos kerja yang tinggi sehingga mampu bersaing di tingkat internasional dan berperan aktif dalam pemberdayaan masyarakat melalui penerapan iptek bidang pertanian berlanjut serta manajemen bisnis.
Hello, good morning, everyone.
Good morning, Mr. Ajit.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome to guest lecturing under 3-in-1 program of Fundamental of Soil Science. It's being a great honor for me, Novalia Kusumarini, to welcome you here. Before we go to the program, I would like to express our sincere of gratitude to the Excellency Head of Soil Science Department, Brawijaya University, Dr. Syahrul Kurniawan, lecturers of Soil Science Department, our guest lecturer from University of Nottingham, Malaysia, Associate Professor Ajit Singh, PhD, and all of the audiences who follow this lecturing, both from Zoom and YouTube. Ladies and gentlemen, our guest lecturing will be held in 2 days under the topic of soil fertility management under the tropic. The first day, our guest lecturing is today with the topic of management and maintaining of soil organic matter in the tropics, past and future. And the second day will be at Friday, October 29th, under the topic nitrogen and phosphorus balance to secure crop nutrient uptake. And this morning, we will have a great opportunity to learn about managing soil organic matter with the expert, Dr. Ajit Singh. Before starting the program, I would like to greet Dr. Singh. Dr. Singh, welcome to University of Brawijaya in Malang, Indonesia. Even though you are in Malaysia now, but I am pretty sure that your heart is here with us. Exactly. Thank you for your time, giving us a great knowledge and experience today.
Thank you very much.
Thank you, sir.
Yeah.
It's such a pleasure to have you here. And before we start the presentation, allow me to invite Head of Soil Science Department, Dr. Syahrul Kurniawan, to give the welcoming speech. Dr. Syahrul, time is yours.
Okay. Thank you very much, Bu Novalia. Good morning, everyone. First of all, would like to thanks to Dr. Ajit Singh from University of Nottingham for the
Dr. Syahrul, I'm sorry, we cannot hear your voice clearly.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Is my voice clear now?
Yes, it's clear.
Okay. Yeah. Sorry. Okay. First of all, on behalf of the Dean of Faculty of Agriculture, University of Brawijaya, we would like to thanks to Dr. Ajit Singh for the time to give a guest lecture about the management and maintaining of soil organic matter in the tropic, past and future, in the under the program 3-in-1 program for the course of fundamental of soil science. As the moderator say, before that, the 3-in-1 program is try to give knowledge or share experience to the student from the lecturer from the outside or from the foreign university, and also from the practitioner from Indonesian. So by this program, we hope that the student in our university get a lot of knowledge or a new knowledge and experience, and also practical application, related to the basic fundamental of soil science. So we hope the student will increase their competence, and hopefully after they graduate in the agroecotechnology program, they can apply this knowledge and also experience to their work. So that's I think that's from me. Last, would like to thanks again to Dr. Ajit Singh, and I hope also all the organizing committee for the 3-in-1 program of fundamental of soil science, and I hope this course will be held and success. Thank you very much. And Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Syahrul. Moving forward to the main agenda, we are really happy to learn about managing and maintaining soil organic matter in the tropics. Since organic matter provides numerous benefits to physical, chemical, and biological properties of soil, so maintaining soil organic matter can also be maintaining soil fertility as well, that beneficial to the growth and production of our plant. And today we will find the answer how to manage and maintain soil organic matter, especially in the tropics, since we are in the tropical country. Indonesia and Malaysia is a tropical country. And before, allow me to read the curriculum vitae of our guest lecturer, Dr. Ajit Singh. Dr. Ajit Singh he is the associate professor in agronomy and biostatistics, University of Nottingham, Malaysia, and he gained the degree in University of Nottingham, University of Ibadan, Nigeria, and University of Allahabad, India. And he gained a lot of publications, and 3 of them is written in the viewer. Thank you. And then Dr. Ajit Singh, I'm pretty sure that all of the students cannot wait to hear your presentation. We have time until 12 o'clock for listening your presentation and discussion. And our guest lecturing today is followed by first semester students who take a fundamental of soil science, and also 5th semester of bachelor students who take soil fertility management course. Dr. Singh, time is yours.
Yeah, thank you very much, Iva and Dr. Syahrul, the head of department. And I'm very proud to be connected to University of Brawijaya. And I do have connections earlier. I have been collaborating with Professor Haria and her husband in ICRAF, that's Professor Mene. And I'm very happy to be connected. And I've seen the videos, I've been going through the videos that you started earlier. And excellent videos, lots of focus on agroforestry. And that's, of course, the future is, that's where the future is. And I'm very happy to share my experience with the students and my colleagues. And thank you very much for giving me this opportunity to share this experience from Malaysia, Nottingham. Yeah, I do have quite a bit experience in the tropics, as well as semi-arid in Nigeria. That's where I stayed quite a number of years, and India as well. So tropical experience, semi-arid experience, and subtropical experience, I do have in all these areas, but certainly I spend most of the time in the tropics than other areas. Thanks a lot. Thank you very much, everyone. Thank you very much, Christiani, for communicating with me, and Prayogo as well. And thanks a lot. So I think I will share my screen. Okay, can you see my screen? Are you able to see my screen?
Yes, it's clearly.
All right, thank you very much. So that's where our campus is based in Malaysia, in outskirts of Kuala Lumpur. And I'm an agronomist, basically. So you know what agronomy is, crop production as well as soil management. We do not have agronomy program per se here in University of Nottingham. We have a biosciences department, we don't have Faculty of Agriculture, but it's biotechnology, which under biotechnology, we have different streams. So we have plant science, pharmacy and health science, and industrial biotechnology. So we have under different streams under biotechnology. So I am under plant science stream here. Then we also have nutrition program. But we do conduct a lot of research work under sustainable agriculture. So that's where my area is covered. So I have quite a number of students working on sustainable agriculture related to soil as well as crop production. So I'll briefly go through some of my research, some of them. The other one I'll cover later in on 29th. Okay. Now this is a work on a PhD student working on Moringa. As you all know, Moringa it's a wonder crop. It has lots of utilization and medicinal purpose, and I think you all know that, those in the tropics as well as working in agroforestry. But one of the challenges has been the germination is quite poor, and as well as its multiplication. So this student is trying to study how we can enhance the seed germination as well as multiplication using propagation using cuttings and different budding techniques. So she's currently on field trying to study the biochar as well. What effect will biochar have? You know, biochar, it has recently been a very popular soil amendment because it adds carbon to the soil and holds lots of nutrients and microorganisms. So it has been quite successful, and a lot of research work has been happening on biochar. So we are trying to study that in the field here. This is another student, the biostimulant. Recently, the biostimulants have also been very popular. So lots of biostimulants have come up, a lot of companies have come up that are able to produce biostimulants that are claimed to increase the growth of the plant. And how does it increase? Still not very clear, but they do claim that it does well, it grows well. So this is something related to biostimulant. We see what the physiology is. We study the root physiology as well. So we have root scanners that are able to scan the root and the root area, root volume, and surface area. A lot of parameters that are very useful because roots play a very important role in terms of nutrient uptake as well as tolerance to drought. So a lot of study, a lot of focus we have at University of Nottingham on roots. We do have root scanners as well as root imaging techniques, and that's a quite expensive technique, but it's not available in Malaysia here, but it's available in the UK campus where you can take, you can scan roots on the field. So this is something very useful, something that has been happening and quite useful to climate change and productivity. This student is based in South Africa, and she's working on amaranthus. You know, amaranthus is a C4 plant, drought tolerant, and there is a future in this particular crop. So we are trying to study how this crop will be able to tolerate climate change. You know, we rely on very few crops, 3 or 4 crops, at least provide us with 60% of our calories. That's right, wheat and maize. So one of our target is, and not us, but everyone, all the agriculturists, that we must diversify. We must try to look for underutilized other crops that can do well in an event of failure of the crops that we heavily rely on. So this is amaranthus. We are trying to see how this crop will perform under drought stress conditions. So we are trying to take all the observations and fit it in the FAO aqua crop model and predict its yield under different climatic conditions. So this is something quite interesting in terms of climate change. The most interesting and relevant to you all is that's based in Indonesia and is being, Alan Purba Kusuma, and he is based in Musimas in the northern part of Indonesia. I'll show you the location. and he's being co-supervised by Professor Hariha. In fact, she is the she developed the proposal and designed everything. So this is a very interesting work, and we are trying to get quite good number of publications from this. So I also happen to see, visit Indonesia and see how the work has been progressing, and share experience with Professor Haria and see her fieldwork activities. Very excellent work that she has been doing in the area of agroforestry. So the objective in this case is actually there is a huge plantation that has been cut down, and huge mass is being produced out of this, and that is going to be recycled. So what are the changes? What's happening to the soil? How is the decomposition happening? Everything is being monitored in this particular experiment. So the focus here is the first experiment. There are quite a number of experiments here. So the biomass, how much biomass is being produced per unit area, and how much is nitrogen in the stock or carbon that is going to be stocked in the soil if we return the residues back into the soil, and what are the decomposition, how is it happening in using a litter bag. So this is something that is that has happened, and I will share but just few results anyway. So this is where the experiment is located in Riau, Indonesia, and the place is Musimas, and Alan is a staff there, and at the same time he is our PhD student. And in fact, most of the work is happening in Indonesia, and all the research work, including the analysis and all the guidance in Indonesia, is done by Professor Haria. So these are some of the pictures on the trunk, all the measurements being taken on the trunk to quantify the mass of the biomass per hectare. These are the litter bag samples to monitor decomposition, and these are the activities happening on the field. So very interesting, and I had a good opportunity to share this experience with Professor Haria in your soil science department. One of the results that is relevant to this particular topic is the total dry matter. You can see, you can imagine how much dry matter is being produced here. 83 tons of dry matter per hectare, just 1 hectare. That's quite huge. And this dry matter will contain nutrients like N, P, and K. And assuming this dry matter is being exported or burnt, so you can imagine the consequences of this. So if it is being returned to the soil, then certainly we are going to gain a lot of benefit out of this. So if this is returned to the soil, then we can save at least 1,163 kg of urea, and that's quite substantial. So that shows the importance that we must recycle these residues back into the soil, and for the purpose of crop productivity, increase our productivity, increase soil structure, and as well as mitigating climate change. That's something that we'll discuss later. I mean, in a way, we are trying to increase the carbon content of the soil by incorporating these residues into the soil. And had it been, if it was burned, then certainly everything will be released into the atmosphere, increasing the CO2 concentration. And increasing CO2 concentration means increasing greenhouse gases. Increasing greenhouse gases means that there'll be increase in temperature, there'll be global warming. So that's why there's a need for us to recycle these nutrients back into the soil. If you see this, the N content of these different parts, trunk, radish, and leaflet, and you can see it's quite low, except leaflets, which is quite okay in terms of decomposition. Now the decomposition, the rate of decomposition is also determined by the CN ratio, which is 17 here, which is less than 20. That's quite, the decomposition is going to be quite fast. This is 100, very high. The CN ratio is very high. So the decomposition is going to be a bit slower, okay? Now, this is a litter bag study. You can see that the one with the lower CN ratio of 17 has decomposed faster. Not very fast anyway, but still faster than the one with the CN ratio of 102 and 98. So this shows that CN ratio of 17 has decomposed faster. Almost 10% of the residues remain at the end of 48 weeks after it was inserted into the soil. So it took 48 weeks to reach at least 90% decomposition. So this is something very relevant to what I'm going to discuss now, the CN ratio, the amount of biomass that is being produced. And this is our team here. Yes, that's Prof. I think you all know her. Very active, very, active in agroforestry, very active on the field. And I really got good experience with her in Indonesia. And that's her husband, Professor Mene, and agroforestry. And this is all the team here. We have others here from Musimas. Yeah. So this is what's happening here. So after filling we are going to monitor the residue decomposition process, and then we are going to replant with new plantation. And in between the oil palm rows, we are going to interplant with annual crops, at least to make use of the space in between the two rows of oil palm. So this is what's happening. We are trying to make use of the space in between the two oil palm rows. So that's interplanting maize and other crops. Now, another student also from the same company, Musimas, is Ardina, and he has worked on the soil properties. What impact will the management practice? We have rows here in between, a lot of movement here. Then we have a lot of residues falling on the ground. So what impact will this management practice have on the soil properties? So he has completed his master's through research from our university, and he has defended his thesis successfully. So congratulations to him, and he has done excellent work, and we are trying to get this published along with Professor Haria. All right, now back to our main topic here. Considering what I've just discussed, the importance of organic matter, not only for productivity, but also for mitigating climate change. You can see the amount of biomass that is being thrown or being put on the soil surface. And assuming this was burnt or used for some other purpose, then certainly we would lose this organic matter. And why? Because you can see that the global warming is happening, climate change is happening, and this becomes very important, more so that our focus currently of all the government is to be net zero. So net zero means that we should not emit any greenhouse gases. I mean, this is something achievable. We must achieve it, or else you can see lots of floods happening, lots of drought happening. So you see floods even in Middle East where it has never rained, in Oman, in Saudi Arabia. So that's climate change. It's happening. We must accept that, yes, climate change is happening. There is an increase in temperature. Look at it here compared to previous years. Look at the increase in temperature. So there is no doubt about that. So this is not only going to affect the humans as well as plants too. It's going to affect the plant productivity. It's going to affect the yield of the crop and eventually the food security. And there is a meeting happening, COP26. Recently, it's coming very soon, and there's going to be discussion on that. Okay. So now, with reference to that, we now come back to our organic matter, and you can see how important it is, because it not only improves our productivity of crops, but at the same time, it's very useful for climate change or mitigating climate change. Now, what is organic matter? I think you all know that. It's something that is very simply defined as plant and animal residues that are incorporated into the soil and that decomposes into humus, which is the end product. But well, there are a lot of theories behind that. Some say that is decomposed organic material, the humus, but a lot of people say that it's a continuous process. So we have humus, we have a lot of microorganisms that are living, and we have residues that are undecomposed and residues that are in the process of decomposing. So it's a continuum, it's a continuous process. Okay, so we cannot just clearly say that the humus is the end product or organic matter is the end product of the residues, plant and animal residues. So it's a continuous process that is happening, and it has around 10 to 40% microorganisms and 40 to 60% humus, and it's mostly plant and animal residues, which is of course dominated by plant residues. The CN ratio plays a very important role in the decomposition of these residues that we add to the soil. So this is a diagram that will help you with that. If the CN ratio is greater than 2.5, then yes, the decomposition is going to be faster. Then we also look at lignin and polyphenol contents as well. It's not simply the CN ratio. We have to look at lignin content and polyphenol content. If it is lower, yes, then you can directly incorporate into the soil with the annual crops. So high N content, more than 2.5, it has lignin polyphenols less than 15 and 4, yes, directly incorporate it into the soil. And if these values are greater, then you have to mix with fertilizer. Yes, we have to mix with N fertilizer to make the decomposition faster. But if the CN ratio is not greater than 2.5, and then that's where the problem comes in the decomposition, and the decomposition will not be faster. And if the lignin content is less than 15%, then we have to mix fertilizer or add to the compost. We have to compost it first before we add it to the plants or to the plot, or else this might create a temporary shortage of nutrients. So we have to be careful, and the decomposition process might increase the temperature, so that might damage the crop as well. So it's better that this is decomposed first and then later added to the farm. Then if it is not, then you need to apply it. If the lignin content is very high, then certainly that's mostly with the woods that we have, and sawdust and hardwood, then it's better to apply as a surface, as a mulch for control of erosion and flow of water. Okay, so these are some of the residues we have. This is a grass residue. It has a CN ratio of 82, so it will take a longer time to decompose. Legume residue, which is 16.8, will take very fast, will decompose very fast, and it can be directly applied. Then we have coconut. This is becoming very popular as a media for planting in Malaysia, not only in Malaysia, but also in urban farming, also in fertigation programs. We have programs where hydroponic is being practiced. So this has become a very popular media. So this has very high CN ratio as well. But the highest is the sawdust from wood, which is 500. So this is something that will take a very long time to decompose. So we shouldn't apply this into the farm directly. So if we add this to the soil, then certainly it's going to decompose. There's going to be heat generated. There's going to be energy. That energy is being used by microorganisms for their growth and development. There is water being produced. At the same time, nutrients are being released as well. So these nutrients will be taken up by plants that we grow on. Then finally, it turns into humus. Now, humus is a very complex compound, and the humus might be different from the characteristics of humus might be different from what you have added, might be different from what you have here and what you have added into the soil. So it's a very complex and a very useful compound that we'll see in the next slides how important it is. All right, the composition. If you see the composition of the organic matter, if it's a green organic matter, green plant, then the composition is mostly 75% water and 25% dry matter. Now, this dry matter is produced from photosynthesis here. I think you all know that. That's our reaction of life. And without photosynthesis, we cannot survive on this planet, because plants humans as well as animals, we rely on plants for energy. Okay, so this is the reaction of life. That's the photosynthesis, and this produces carbon, oxygen. That's the glucose, and proteins as well as lipids. So excess of carbohydrate is converted into proteins and lipids. So the dry matter constitutes 42% carbon, 42% oxygen, and 8% hydrogen, and 8% ash. So this ash constitutes the nutrients. We have the NPK, which are the primary nutrients, and calcium, magnesium, and sulfur are the secondary. And then we have the micronutrients, that's iron, manganese, zinc, copper, boron, molybdenum, and chlorine, nickel. So these are micronutrients. We also have beneficial nutrients that help in the growth and development of the plant, particularly in stress or in herbivory. So these are beneficial elements are present as well. Then if we see the compounds, this dry matter in terms of classification in terms of compound, so it's 45% cellulose, lignin 20%, and sugar and starches 5%, protein 8%. We have polyphenols as well, lignin and polyphenol, very important in terms of decomposition, then hemicellulose. Now in terms of rate of decomposition, you can see that the decomposition is faster of sugar, starch, and the proteins, followed by crude proteins, hemicellulose, cellulose, and lastly, lignin and phenolic compounds. So the decomposition here is slower and it is faster for these compounds. Now, in terms of living and dead, in the organic matter, so most of the soil organic matter is dead. That's almost 90%. Only 10% is the living, which is the microorganisms that are responsible for the decomposition, which eventually add nutrient to the soil when they die, when they complete their life cycle. So 10% of living matter and 90% of dead, of which 65% is humus, which is mostly the humic acid, fulvic acid, and some other organic molecules, and 15% is the particulate, and which is that's the resistant organic matter is 15%, very resistant to decomposition. Then we have fresh residues. I told you earlier, it's a continuous process, it's a continuum. So we have the fresh residues and the living ones, and those that have fully decomposed and that have partially decomposed. Okay. Now the humus, the most important part of the organic matter, which is a very complex compound, and it has lots of functions, as you all know that, and it makes the soil dark in color when a soil has a lot of humus in it. And the amount of carbon or the organic matter that we normally have will depend on the soil type, and it can range up to 30%, or it can be 80% in peat soils. But the soils here in the tropics is mostly is 1 to 6%. It's quite low, and that's the reason why our crop productivity is quite low for the annual crops. That's why there's a need for us to add more organic matter, and that will also increase the productivity as well as mitigate climate change. So the functions of humus, very important functions. It forms clay-humus complex. It combines with clay to form a complex which are responsible for absorbing a lot of nutrients, as well as pesticides and other agricultural chemicals. It plays a very important role here. Some of these pesticides are being absorbed to the clay-humus complex, and these are not released to the water. So that at least helps in the control of these pesticides into the soil. That improves also water quality. And by preventing this, it improves the water quality that we take in. And it stores a lot of nitrogen. And certainly, clay-humus complex has a very high cation exchange capacity. It has a very high cation exchange capacity. Look at it. Compare with some organic matter alone and clay alone. So the complex here has a very high organic matter. It has buffering capacity, and is something that is able to, survive changes or manipulate changes in pH and some other activities. It possesses cation as well as anion. Cation, of course, CC, which is reflected by CC, cation exchange capacity. It does have possess anion exchange capacity as well, because it has OH, COH, and we call it a very complex structure that is able to hold the anions as well along with the cations. Okay, so the charges that it has, COH, OH, and some other charges that makes it hold anions as well. And of course, the very important function is the water holding capacity. And I normally consider organic matter as a sponge. You know, when you take a sponge and put it in water and remove it, keep it outside, so it holds water for a very long time. So organic matter is like a sponge, and it holds water for a very long duration. So it has very important function. And some of these functions, you can see that there is a strong relation, I will not say strong, but there is a relation between soil organic carbon and the cation exchange capacity here. So as the organic carbon increases, and so does the cation exchange capacity. You can see it here. Okay, and this is under different clay content. So if the clay content is 0 to 10%, which is this, so low clay content, that's lower cation exchange capacity. High clay content has higher cation exchange and capacity. Okay. Some other benefits of organic matter. Now, organic matter is just like a slow release fertilizer or a coated fertilizer. So as the decomposition proceeds, so does the supply of nutrients. So it acts as slow release of nutrient supply. And it affects directly, it has a direct effect on the growth of the plant, and under so many combined effect of the humus, combined effect of the cation exchange capacity. So it directly affects the productivity of plants. Okay. And it provides energy to microorganisms, no doubt about that. We have microorganisms that decompose on it, get energy out of it, which eventually die and recycle back the nutrients that they have used for their growth and development. So it improves the soil structure, it holds, it binds the soil particles together, and that can also prevent erosion, as well as it will give a good structure to the soil. Provides good aeration. Now, it has two function in terms of improving the structure of the soil. It binds, if it's a sandy soil, it will bind the soil that is very loose. And if it is clay soil, then it provides aeration, it loosens the soil. So very, very, very important function of this organic matter. Okay. Now, the most important function to which I want to relate to is carbon sequestration. Now, this is something that has been there earlier, but has become quite popular nowadays, is the carbon sequestration. So what is carbon sequestration? What does it mean? Okay. So now carbon sequestration is related to the capture of carbon. Okay. When plants photosynthesize, they are capturing carbon. When we add organic matter to the soil is capturing carbon. Okay. So it's kind of capturing carbon means we are trying to store carbon in a more stable state. So CO2 will cause global warming. CO2 is a greenhouse gas. CO2 will increase the temperature. So that's not stable. So when we convert CO2 into the carbon, that's biomass, we are making it more stable. When we are converting it, we are adding it to the soil, and the soil holds the organic matter as well as the soil, then it's more stable. So converting it to solid or in a dissolved form makes it more stable. So that's carbon sequestration. And that's the objective, that's the future. So the more carbon we can sequester from the atmosphere, then less will be the global warming. So if we burn more fossil fuel, if we burn more organic matter, and that means we are adding more carbon dioxide to the atmosphere. More carbon dioxide means more CO2. Sorry, more higher temperature, higher global warming. So that's something that we need to probably take that into consideration. And that's why we now have a concept of carbon footprint. And I think you all know that we assess ourselves in terms of carbon footprint. My carbon footprint is very high, yours is very low. So that is how much carbon do you burn to maintain yourself? That's what carbon footprint is. So if you use too much of petrol, and if you use too much of electricity that is not renewable, let's say if your electricity is coming from coal, that it has a high carbon footprint. Burning coal, almost 50% of electricity in Malaysia is out of coal, burning coal. So that has a high carbon footprint. Traveling with train, where we are traveling in groups, has a low carbon footprint. Electricity is making use of electricity. Sharing your, pooling your car for, going to office, that has a low carbon footprint than riding alone. So there are a lot of things that are involved in it, and we use that to assess ourselves whether our carbon footprint is high or low. Okay. So this is carbon sequestration plays a very important role, and that's where agroforestry or forestry will play a very important role. It has quite significant contribution in adding organic matter to the soil. Now you can see the statistics here. The carbon storage is the highest in the ocean, which is mostly inorganic form, and then followed by soil. You can see how much carbon it is storing, almost more than 2,500 gigatons of carbon, and peat and wetland. You can see how much storing, almost 200. Plant litter, almost around 50. Atmosphere is holding up to 600. So the amount of carbon in soil is almost 3 times that of atmosphere. Okay. Then the living organism, all living organisms above the soil, that is including plant itself, the plants that we grow, is everything combined is up to around 600, 5 to 600, 650. So this is, you can see the carbon storage in the soil is quite high. So that's where it becomes very important for us to maintain that soil organic matter, manage it, improve it, increase it rather than reduce it, because that will not only increase our productivity, but as well as mitigate climate change. Okay, and that's a serious concern currently. So out of this 2,500 that we have, organic is 1,550. Now, organic means those carbon that are associated with organic compound like protein, cellulose, carbohydrate, and inorganic is those associated to, let's say, CO2 is inorganic, and then you have other inorganic compounds, bicarbonate and carbon monoxide, some other forms of carbon that are inorganic might be, let's say, there are some other soil bicarbonate, yes, is one, sodium bicarbonate, and these are stable anyway. CO2 is not stable, but there are other stable compounds inside the soil that are inorganic. That's particularly the lime, that's sodium, we have sodium bicarbonate and some other compounds that are inorganic. So this is very important. Now look at the cultivation, the arable farming that we do, particularly the annual crops. So we have 170 billion hectares of land that is crop-based currently. And the carbon stock for this is 170 gigatons. So in this case, the amount of fertilizer that we add lots of fertilizer to get this yield, and the CO2 that is being released due to this application of fertilizers and pesticides is around, this is hidden here. Okay, so quite a number, I think 50, I can see it here because there's something hidden. So I think around 50 gigatons of CO2 that is being released out of this system. So you can see that this is a system that is of concern. We cannot say that it's highly sustainable. Okay. Now soil organic carbon is still on soil organic carbon. So every ton of soil organic carbon releases 3.67 tons of CO2. So if you burn 1 ton of organic matter, you are releasing 3.67 gigatons of CO2. Imagine what this will do to the atmosphere. Then this all depends anyway. It all depends on the soil type, climate, and the management factors. If you're able to manage it well, and then certainly we can prevent this loss of CO2 into the atmosphere. When soil decomposes, it does releases CO2 anyway, but that's something that is happening, is normal. But we should try to make it, we should try to avoid too much release of CO2. We should try to have some practices, some that are more sustainable, that will at least reduce the release of CO2 and will help in fighting climate change. Now we can always convert organic carbon, which most plants sequester, and we always compute organic carbon when we analyze organic matter content in soil. The value we get is organic carbon, and to get our organic matter, we multiply by 1.72. That's an index, that's the coefficient that we normally use, and which is based on 58% of mass of organic carbon. Organic matter is carbon. So 58 divided by 100 divided by 58, that's 1.72. That's why we multiply by this coefficient to get our organic matter. Okay. Now, the challenge here is increasing soil organic carbon. So this is certainly beneficial to our soil fertility. It improves our soil fertility, improves our productivity as well. So this is something very critical. We must increase it. And not only does it increase the productivity, but also it helps us mitigate or fight climate change. So it becomes very important in terms of productivity and in terms of maintaining soil organic matter. Now, why is this important? Now our population continues to increase, and it's expected to be around 11 billion in 2100 and 9.8 billion in 2050. So there is an increase in population, and there is a need for us to increase the productivity as well, the crop productivity. And we must increase, we know we all rely on rice, wheat, and maize. So we must increase the productivity of these crops by 60% to meet this demand by 2050. Okay, we must do that. In order to do that, certainly we must make sure that we have a soil organic matter that is highly sustainable, soil organic matter that is more healthy. Okay, so only when the soil is healthy, then only we'll be able to improve the yield. And certainly to achieve this, we have to work towards the productivity as well in terms of improving new varieties. So not only the soil, we have to work on getting new varieties. We had green revolution. There was a green revolution in 70s, and that led to increase in yield of wheat and rice, at least 4 or 5-fold. So similarly, we need a green revolution. We need varieties, improved varieties that can bring about new green revolution. So it could be improved varieties, or it could be soil management as well. So that is something that we need to see what happens in future. So that's where the soil organic matter becomes very important. This is, so I will quickly take you through managing and maintaining soil organic matter, what has been practiced before, and what's happening now, and what probably will happen in future. So that's my colleague, Professor Arya, and her husband at Musima's plantation, and that's Alan, our PhD student. So how do we manage? Now, I've summarized everything here in one slide. This is based on Food and Agriculture Organization and some other sources. Now, what we have been practicing before and what we are currently practicing is very difficult to distinguish, or make a line. So there are some practices which we have been practicing, we are still practicing, and we will be still practicing. In fact, frankly speaking, we are going back to our past. I mean, the past, what we practiced agroforestry, we have been practicing our agroforestry before, thousands of years ago. And we have been practicing rotation. We have been practicing soil conservation. So the future, that's where the future lies. So in fact, we are going back to that system. So that is our future. And in fact, I would say that is our future. But certainly we need to work, we need to develop new varieties. We need to develop new means of improving it, or else the old system that we have been following, no doubt is sustainable to meet the demand for the population that is coming up in the next 20 and 30 years, probably will not be possible. So we need other techniques. We need other techniques in terms of improvement in the crops, new varieties, as well as the old system. So we need to combine everything and come up with something that will be able to meet the demand for the population in the next 30 years. So I've quickly summarized here. So I've divided into two. Management practices that decrease organic matter. This is something red. So this is something we shouldn't practice. Then we have management practices that increase organic matter. Now decrease in, so this is further divided into three: decrease in biomass production, decrease in organic matter supply, and increase decomposition rates. Okay. Now increase decomposition rates, I told you earlier, there should be decomposition, or else the organic matter that we add will not decompose. And just imagine if there are no detritivores, those organic organisms that decompose, what happens to our food waste, what happens to our plants and animals that die. That will be terrible. So decomposition will happen, but we should not increase it. We should not manage, we should not follow some practices that will increase the process to a very high extent. Okay. So decrease in biomass production. So like replacing trees for annual crop production. So too much of annual crop production. That means, cutting down the forest for growing rice. You see, so that will decrease the forest. And forest is a very high carbon sequestration. So it stores a lot of carbon. Then replacement of mixed vegetation with monoculture. That's what we have been practicing. Most of the companies are into monoculture production of oil palm. So monoculture has a lot of demerits. So if we do that, certainly we are just practicing one, and in an event of any failure or in an event of any insect or pest attack, then it's likely to affect the crop, because when we practice intercropping or rotation cropping, we have varieties of crops and we're able to control pests and diseases. High harvest index. Harvest index is the proportion of dry matter that is transferred or translocated to the grain that we consume, or tuber that we consume, or the oil palm seeds, the seeds from which we get the oil. So if we have a crop that has a very high harvest index, most new varieties have high harvest index, then that's likely to deplete the soil of organic matter. Then bare fallows, open fallows, that you all know that if it is open, it's likely to, there is no biomass production. Then decrease organic matter supply. If you burn the natural vegetation, burning, something that is very serious, and that burns, releases CO2 into the atmosphere, causing global warming. Overgrazing, too much of grazing of animals. Removal of crop residues. If you remove it, certainly you are removing the organic matter, and as well as the biomass. And tillage, if you do too much of tillage, that increases the decomposition. It's good for annual crops, no doubt about that. But certainly it increases the decomposition process. There's loss of organic matter along with the runoff and so on and so on. Drainage. If you go to the Western countries, a lot of money is spent on drainage below the soil. So you can imagine, below the soil. So it means there's more irrigation. There's, a lot of problems associated with the installation of drainage and drainage pipes. So that can increase the decomposition rate as well. More aeration. Okay. Then fertilizer and pesticides, of course, do affect the release of CO2, and they do increase the decomposition process as well. Now, what we should practice here is to increase the organic matter production. Okay, so we must increase the water availability to plants in case of drought, in case of arid areas. We have a lot of serious water problems. So we have irrigation facilities. A lot of money is spent on irrigation facilities. Do I need to share screen again?
Yeah. Yes, your share screen is off.
Okay. So
you cannot see your presentation.
Okay. Okay, is it because I do not have license for this? Okay, let me share again. Yeah. It's only sharing a screen. Can you see my screen? Are you able to see it?
Yes, sir.
Yep.
Okay, okay. I think it's because, we use more Teams. So it's probably for only 1 hour. Yeah. Okay. So these are practices that probably some of these practices we have been using it, and some of these practices certainly will be the future, and we have been using for a very long time from history, and some of these practices, of course, have been, especially on this side, have been being followed by plantations which are not sustainable. They are beginning to realize that, and they have been coming up to agroforestry. I think it's because of, I think you have a license probably, and mine isn't. We use more of Teams. That could be the reason for this. Yeah. Okay. Can you see it?
We can clearly see your share screen.
Let's try again. I think it's because of the license. Yeah. All right. So I've listed, these are the practices that it has the potential to increase the organic matter and increase the biomass production, as well as decrease decomposition rates. So this has been summarized here. And you can see that we have cover crops, something very, very, very important in the plantations nowadays. Cover crop has lots of functions, improves organic matter, and prevents direct contact of the rainfall with the soil. So very less runoff, and maintains temperature in the soil. So very, very important. Cover crop has a very important function, and a lot of plantations. Yeah, can you see it, my screen?
Yes, we can see your screen, but it's still in the slide number 5.
Really? Okay.
Yep.
I'm coming, please. How about now?
Still the same, sir.
Really? Let me share again. Sorry about that.
Doesn't matter.
Mhm.
Can we?
I think is the license. I think we'll try to rectify this.
Probably you can share your presentation to Bu Kristanti, then the committee will help you to share your presentation.
Okay, let me do that. Yes, that's a good idea. That's a big file. Let me make PDF out of it. A little better. Is PDF okay?
Sorry, sir, the committee of your share screen because we are live streamed also in YouTube.
Okay. Sorry about that. Yeah. It's a very big document. I think that's why it's taking time to save it. Yeah. Let me see if I can share the PDF. Sorry, the original, which is. So I just drop in the Zoom. Is it? That's how is it done?
Not yet. We cannot see anything. Probably it's still in uploading process.
Okay, it has done. Let me do that. How do I do? I just drop it in the chat box, isn't it?
We cannot see it yet.
I'm coming. Just yeah.
We still not received any document for you from you.
Yeah, I'll do that. Just 1 minute. Yeah, sorry. Okay. Is that okay?
Yes,
okay.
We have received it. Thank you.
Yeah, sorry about that. Let me see. Let me share the screen again. Yeah, I'm able to do that. I don't know the reason why. I think it's okay now. Okay. Are you able to see the slide, the 26 slide? 26?
Yes, we already get your materials.
All right. Can you see the slide number 26? Or still 4?
Yes, it's the previous slide you present.
Okay, that's fine. Okay. So, I mean, these are a list of practices that we have been practicing for long. We are still practicing, and there are some that needs focus, and which probably will be the future of the management practice that we'll try to see, so that we'll be able to increase productivity and fight climate change. Okay. Yeah. Now, these are some of the results that have been obtained by various researchers. You can see that tillage. Now, tillage is something very, very important. The more we till, the more we disturb the soil surface, and more likely that is going to nutrients are going to be eroded or washed away, as well as the organic matter. And certainly, we have lots of crops that cannot do well without tillage, and we do have to come to that balance so that we'll be able to come up with a good crop. And that's where reduced tillage, minimum tillage, and people have been practicing zero tillage as well. Even in previous, probably 30 or 40 years ago, people did practice zero tillage, and that's where the future lies, as you can see here. So you can see direct seeding, that's no tillage at all, and you can see how much organic matter it has accumulated here. Then in terms of, sorry, this is lost. So the maximum lost was in the normal tillage, 4,300 kg per hectare, MB, moldboard, plow 2,200, disc, chisel, these are all mechanized farming. So huge losses in the mechanized farming here, while direct seeding just 860. So these are zero tillage being practiced, no tillage at all. So maize being grown on mulch. And similarly here, mulch acting like a cover crop here. So direct tillage here as well. And you can see zero tillage having more carbon, higher carbon in zero tillage. This is a rotation system where you have zero tillage, pigeon pea, and maize. So it's a rotation system. And this rotation system has accumulated.
Maybe
Your
we can
presentation is
your
off
message.
again. Would you please to the committee to share your presentation?
Yeah. Yeah, thank you very much. I think is the license which we have. Okay, thanks a lot. Yeah. So these are some of the practices. Like for example, we also have conservation agriculture, conventional tillage, and yes. Okay. So this is carbon sequestration, carbon storage, carbon stock in the maize and mucuna. Is kind of rotation system. So you can see cover crop has increased the CO2 in the soil. Okay. Yeah, next slide, please. So similarly, we have the conventional tillage and conservation tillage being practiced. And you can see that this has improved the population of Bradyrhizobium is a bacteria that is responsible for N fixation. So not only carbon, but it has also increased the bacteria as well. Then this is another study where you have the conventional tillage and then the no tillage. So you can see that no tillage has accumulated more carbon as compared to the conventional tillage that we normally follow. Now, this is a very long-term experiment, and there was an introduction of soil conservation study in 1975. And since then, there has been an increase in the organic matter content. Okay, so very long-term study, and that shows that conservation does work here in this case. Again, this is direct seeding. You can see the organic matter content has increased in direct seeding, followed by minimum tillage, and least in the conventional tillage that we normally do. Now, this is the effect of crop residue. So crop residue burning. So burning, something that is quite a serious concern now. So the burning, so those without burning, you can see the amount of organic matter that it has currently quite high in the top layer, 2.5 centimeter, while without those that were burnt, and look at the amount of organic matter has reduced. Okay. So burning also does reduce the soil organic matter content. Next slide, please. All right, this is the typical system that we have currently, and unfortunately being practiced by a lot of our plantations, and where their objective is the profit. But I will not blame all, but certainly it has been in practice for quite some time, and recently, very recently, when there has been ban on oil and concerns by European Union and some other countries, and on the deforestation and animal welfare and sustainability. So that's where lots of plantations have beginning to practice sustainable agriculture. Or else, look at this case here. Now, this is a typical oil palm, lots of nutrients being supplied, and sometimes more than what is being required by oil palm. farmers or plantations add lots of nutrients, and some adding nutrients without even analyzing the soil. So it's not a balanced practice. So there is a lot of addition of fertilizer, a lot of pesticides that does affect the soil microorganisms, and huge amount of food is being harvested, 20 tons per hectare every year almost, and residues are being exported. And some of them, they prefer a clean cultivation. They want to remove all the residues, want to keep the plantation very clean. So that's clean cultivation, and there is remove the residues, and certainly is supposed to be ideally returned back so that it decomposes at organic matter to the soil, but it is being exported for a different purpose. There is a lot of erosion, there's runoff erosion, there's a lot of bleaching as well because of direct contact with the soil. There's very high rainfall in the tropics, very high sunshine. So this results in a system that is highly unsustainable. And we call this system monocropping, and it's quite common in the plantations and in other mechanized agriculture, even in annual cropping system as well. So in order to maintain this fertility, in order to maintain very fast runoff, maintain this fertility in the soil, and maintain the nutrients that has been harvested every year, we must add organic matter. We must replace organic matter. We must make sure that organic matter content in the soil here that holds the nutrient is maintained, if not improved. Okay, so it's very, very important for us to do that. Okay. Yeah, next slide, please. Yeah, the management practice that we can probably follow in the future is the conservation agriculture, and then also sustainable production system. So we cannot just meet the demand for our population by just the conservation technique, but as well as the sustainable in terms of improving varieties in terms of use of fertilizer. We need to develop varieties that are highly fertilizer efficient. We need to develop varieties that are water efficient. They have high water efficiency. We need to increase the food production, increased biomass, okay? So, and reduce use of herbicides and pesticides, okay? Increase biodiversity. We need to have more plants, more diverse plants, rotation system, intercropping, relay cropping, and as well as integrating livestock into our system. We must integrate livestock into our system so that the two can supplement each other. Okay. Then under this conservation technique, we also we have discussed a lot about this minimal mechanical soil disturbance, permanent soil cover, that's cover crop rotation in terms of managing soil organic matter, in terms of maintaining soil structure and texture. Then other two very important that might be very relevant currently is increased carbon sequestration. This is only possible when you add more carbon into the soil, when you have good management practice so that nothing is lost from the soil. Then establish soil information system. This is something very, very important. We must know the soils that we are working on. Each farmer must know the soil type that he's growing crops on. So we must maintain a database where the farmer can easily obtain the information available on the soil. So this is becoming very important, and we call it IoT, Internet of Things. IoT, this is very important, where all the database is entered into a software that can be utilized by the farmers. Yeah, then we have climate smart agriculture that has been, it has been in practice and is being educated by Food and Agricultural Organization. So their target is to increase the agricultural productivity and income sustainably, following these practices here. Then building resilience to climate change. So we must have a system of a crop production system that will be able to resistant climate change, a management practice that can adapt to climate change, that can resist climate change. That's something very, very important that will determine by making use of resistant varieties and tolerant varieties, practicing systems that will probably will not lose too much of organic matter. Agroforestry, certainly very highly sustainable system. And reduce emission, removing greenhouse gases, wherever possible. Yeah. So this is something where climate smart agriculture is becoming very important. Next slide, please. All right, now something that has become very common, very popular nowadays is the soil health. And for the, I think, past 5 or 6 years, and a lot of focus on soil health, which deals with soil quality, soil condition, soil tilth, and soil conservation. I mean, these are new techniques, new terms. It has been there. And somebody in the West develops a term for it, and people start using it. But we have been doing that. We have been practicing in Indonesia, in Malaysia, and other countries. I mean, it has been there already. Just something, since we are in academics, certainly we need to make use of these terminologies to at least stay update on it. Now, this is related to carbon sequestration. Now, soil health, very much related to, tied to soil health and carbon sequestration and soil health, which means that more carbon sequestration means that more healthy soil. So more carbon sequestration means that we are adding more organic matter. It's the same thing. So adding more organic matter to the soil, practicing more of agroforestry. Agroforestry is a system that adds lots of organic matter to the soil. Okay, so this is something that we can adapt to at least mitigate climate change and improve productivity at the same time. Okay, and then there are 4 principles of this soil health. The principles are maximize soil cover, minimize soil disturbance. Soil cover means cover crop, keep it covered all the time, and so that less erosion, less runoff. Then minimize soil disturbance, less tillage, continuous living roots that continue to grow crops, rotation, cover crop, agroforestry. Then maximize diversity. Yes, maximize diversity. That means you have diverse group of crops. We don't rely on only one crop. We have lots of different types of crops. We have oil crops, forage crops. We have carbohydrates, cereals, legumes. Legumes are very important in any system because they do not take up nitrogen. We don't need to apply fertilizer. They are self-reliant. They are able to fix nitrogen, add nitrogen to the soil as well. So very important integration of legume into the cropping system. Then integrate livestock. Yes, make the system so that the crop and the livestock will supplement each other. Okay, so this can be easily done, and this is by planting lots of trees, growing perennials. Perennials are very important because annuals will easily complete their life cycle. Then the land will remain idle, exposed to erosion, exposed to direct contact with rain and direct, and in some cases burning as well. Residues, disturbances are burnt in India, in the northern part of India, and there is this haze program every year, similar to haze in Indonesia and Malaysia. That the source is the burning of residues. Okay. So therefore, the soil health, which relates to carbon sequestration and which is able to fight climate change, is very, very important. And this actually modifies the bulk density of the soil, the aggregate stability of the soil, and the soil organic carbon. Okay. Just next slide, please. Yeah. So this is summarized, all the cultural practices summarized. This is from United States Department of Agriculture. So this is the practices. I'm not going individual of each. I think we all know what crop rotation is, relay crops, forage crops. And the idea for all this is to maximize continuous growing of crops, continuous living roots into the soil. That will add more organic matter. So crop rotation, cover crops, perennial crops, and this is something quite common in agroforestry. With the practice that very common. Then diversity, crop rotation brings about a lot of diversity. Rotation, we rotate. This is grazing, so we have rotational grazing. Then, of course, IPM, we must practice IPM, pollinator planting. Now, this is something quite common. Pollinator planting means we plant those crops that attract bees, pollinators. Is particularly useful for annual crops where pollination is quite critical. So we should take care of that as well. And legumes, integrating legumes into the agroforestry, legumes into crop rotation, relay cropping, intercropping, that is something going to be future and very, very useful. Okay. Then minimize disturbance, don't disturb too much soil, go for no-till or minimum tillage, and then maximize soil cover cropping. I can see mucuna everywhere in all the soil plantation because mucuna is a legume. It has 3 to 5% of N in its hum in the store. So when it's brought back to the soil, that will add organic matter. And then certainly we must balance that. You're adding mucuna, then you must make sure that you add less nitrogen to the soil. So if you add a lot of nitrogen along with mucuna, certainly you are wasting a lot of these fertilizer and other resources. Okay. Yes, next slide, please. All right. So this is something that we can summarize everything into increasing biodiversity and living roots by practicing diversified rotation, cover crops, agroforestry, amendment, application of compost and manures, crop livestock integration, and also biodiversity, presence of living roots. So these are practices that will increase the organic matter content in the soil, will suppress weeds and recycle nutrients, and also increase the organisms in the soil, microorganisms that are responsible for decomposition, and that will help in the recycling of nutrients as well. So we have crops that are deep-rooted, crops that are shallow-rooted. So there is recycling of nutrients from the subsoil to the topsoil. So a lot of things happening when we practice intercropping and crop rotation, and those are practices that are highly sustainable. Yes, next one. Then again, we must make sure that we have diversity of crops. So we have legumes, we have deep-rooted crops, legumes, then cereals that are shallow-rooted. We must get all that combination to diversify. We must have crops that are underutilized, a lot of focus on underutilized. We have crops that are underutilized, that they are able to tolerate climate change more than the crops that we are currently growing. So we must tap those crops and grow them in our agroforestry system or even in production system. Yes, next one, please. Yeah, these are the practices that are likely to reduce, minimize disturbance and maximize soil cover. That's agroforestry, cover crops, and that will certainly reduce tillage. That will certainly have minimum disturbance on the soil. You can see cover crops here in plantation in Musimas, and this is the, I mean, my colleague, Professor Harian, is very expert in that, and she has been practicing that, and I also will agree that that is the future, and I agree with that as well. And I'm not into agroforestry, but I'm into annual crop production and also into urban farming. But certainly agroforestry holds the future, no doubt about that. Yes, yes, next one, please. Yeah, so I have prepared this diagram showing you the agroforestry system, and you can see that huge amount of organic matter is being trapped into our soil, 1,500 gigatons. That's quite huge. So we must maintain, we must improve that in order to sustain the productivity of these soils. Okay, so this is a typical agroforestry system. So we are integrating livestock into it. We have trees like albizia. This is a tree, is a legume tree. It has nodules that can fix nitrogen. Then we have leucina also, and that also fixes nitrogen. So it's a shrub, and we try to cut these shrubs when they are young. Leucina grows very fast. So we cut down the foliage of this shrub into the soil. We till it into the soil, we allow it to decompose, or we practice minimum tillage depending on the agroforestry system. Then we now grow maize and beans, that's the annual crops, and we get a good yield without adding any fertilizer, without adding any pesticide. So this is a very sustainable system. The leaves that fall, they decompose and there is nitrogen fixation happening. And there we have mixture of trees, mixture of shrubs, and annual crops. Lots of nutrients are being recycled from the subsoil to the topsoil. So very effective, very efficient system of agroforestry. So when we have animals along with forest trees, then we call it silvipastoral. When we have crops along with trees, then we call it agri-silvipastoral. Then we have mixture of all the three, crops, trees, and livestock, then we call it agri-silvipastoral. So this is the future in the tropics, I would say. This is the future in tropics, and we should probably practice something similar even in other areas so that we do not till too much of our land and make the system more sustainable. Yeah, next slide, please. Yeah, you can see the amount of CO2 that is being lost into the system. The conventional tillage that we practice, and that most of us are practicing, not in the forest, but in other areas where there is a lot of annual crops being produced. So there is a lot of conventional tillage and a lot of CO2 being released, okay, because of the tillage. And tillage actually opens up the soil and increases the decomposition as well, rather than making it a slow release fertilizer, okay? So that also a lot of runoff, and that reduces the soil organic matter as well. So it has, you can see conventional tillage has low soil organic matter, followed by the no tillage, it has more soil organic matter. Then pastures, which are always covered with vegetation, has even more. And again, the agroforestry, the forest has the highest organic matter content and the least CO2 that is being released to the atmosphere. Okay. Yes, next slide, please. Yeah. So this is another study done by a scientist, a review of different systems here, agroforestry system. And you can see that tropical agroforestry system has high above ground carbon accumulation. You can see it's quite high. Temperate is also high as well. And one difference between temperate and tropical, the temperature in tropical countries is quite high. So any organic matter that is added to the soil decomposes very fast because of the high temperature, as compared to temperate countries where the soil remains, a lot of residues remain in the soil for a very long time because of low temperature. And this is semi-arid here, and polar, and then Mediterranean and arid areas. So they do, but highest is the tropical. Similarly for the soil carbon as well, tropical is the highest here, followed by semi-arid and temperate, okay. Then the different agroforestry system here, improved fallows have the highest above ground carbon. Improved fallows means we have fallow that are planted with legume trees and some other crops as well. Then boundary planting has quite high. This is boundary means the plot is being planted with legumes and other useful trees. Okay. So you can see different systems have different amount of above ground carbon. Then soil carbon below is highest in silvipastoral. Now silvi or silva is the same thing. Silvipastoral, that is animal and forest integration. So it's highest here. Then agri-silvipastoral, crop, livestock, and forest. Let's look at it here. So quite okay. They're all positive. In fact, all the agroforestry systems have positive impact on the soil carbon. Woodland has a negative value here. This is, I don't know the reason why, but certainly this is a review that has been found out, but generally the organic carbon tend to be higher. Next, yeah, next slide, please. Yeah. Now, the database, this is something that must be available to our farmers, and this is available on the FAO website. So they do have a database where you can click on the area in Indonesia, and there's a publication on this by Professor Hariha, and she has also made a reference to this. And do read her paper, very interesting paper on agroforestry. And if you click on the particular site, then you'll be able to know the amount of carbon stock here. Like this particular site here in Malang is 21.4 tons per hectare. So this information is very useful in terms of managing the soil, in terms of carrying out any research work. I mean, this is just an example. We can have more details, more nutrients as well. So some of these database must be supplied to the farmers. So the IoT plays a very important role as far as the climate change or productivity is concerned. Yeah, next slide, please. Now, this is a new terminology. As I told you earlier, soil health, regenerative agriculture. I mean, it is happening. It's there already, and our forefathers have been practicing it. And people come up with new names, I told you earlier, and they develop something new as if it has been. It is an innovation, but in fact, it is there. Look at it: crop rotation. The activities in this agriculture is crop rotation, minimized tillage, and mixed farming, and use of manure and compost, use of perennials. So it's saying the same thing. The agroforestry system, the integration of livestock, introducing diversity in your system. So it does improve soil quality, and enhance and improve soil health as well. So that's the objective of this particular agriculture. And it's nothing new, and it has been there. And if you see a video on it, you know that it's the same thing that is we are referring to in the previous slides. Yeah, next one, please. Yeah. So it's just a video that, sorry, we cannot. Yeah, so you can have a, this video is actually referring to regenerative agriculture, and it tells you the importance of, in fact, it's organic agriculture. No insecticides, no pesticides, no fertilizer. So it's pure organic agriculture. And they have tried to adapt agroforestry in the annual crops as well. So they have been growing annual crops without applying any fertilizer. So that's something that probably should happen in future. And then again, I'll also emphasize on development of crops and through biotechnology to develop varieties that are more tolerant to climate change, more tolerant to drought. Along with this soil conservation, agroforestry techniques will probably solve the problem in future. Okay, so yes, next slides, that's the summary. I'm sorry I couldn't show the video. I think I will have to sort this out about the, yeah. So in summary, this is what I can say, that carbon sequestration, very important, something of a concern now because of climate change. And it is directly related to organic matter management, and more carbon sequestration means more organic matter to the soil. And we must make sure that we maintain or improve the organic matter content of the soil in order to increase food productivity and increase the fight climate change as well. Yes, soil health with the practices that we have just mentioned, very important. We diversify our crops, we practice agroforestry, and we integrate livestock into our system and to supplement each other. And that will probably, along with reduced tillage and cover crops, will be able to meet the demand for the growing population. Yes, thank you very much. The last slide. I'm sorry for taking more time. I think I'll plan it tomorrow. And yes, thank you very much.
Thank you very much. Yeah, thank you very much, Dr. Singh. It's a very great presentation of soil organic matter. And I noticed that you have been collaborating with Professor Hairia for several times before. And she comes from our department, soil science department. Indeed, yeah. I agree with you. She is probably one of the brightest professor in agroforestry that Brawijaya has. Unfortunately, Professor Hairia is joining with us this morning. Allow me to greet her. Good morning, Bucho. How are you today?
We call her Professor Cho, and we have met several times, and certainly she's an excellent researcher, and I have had experience with her at Musima's plantation. Yes.
Yes. Here we call her Bucho as well. Committee, would you please to unmute the microphone of Bucho?
I can see that yes, she's online.
Yeah, I am. It was, sorry, hi, Ajit.
Oh, yes.
Yeah, hello, Bu Nova.
Good morning, Bu. Thank you for joining us.
Sure. By the speaker like Ajit, of course, I like to join.
Yeah, probably after later after the seminar ended, we can have a short of discussion between Dr. Ajit Singh and the lecturer of Soil Science Department to discuss about collaborative, a potential collaboration in research to continue the positivity that Bucho gave to us earlier. Okay, well, back to the presentation. I can highlight that soil organic matter is any material produced by plant and animal that returns to the soil and goes through the decomposition process. And Dr. Ajit has many research that proved the application of soil organic matter biostimulant can increase the growth and production of soil organic matter, as well as the decreasing climate change. And soil organic matter will play an important role in achieving global food security. Okay, well, audiences, to all of the students, now we are in the discussion session. Anyone who want to ask some question to Dr. Ajit Singh, please raise your hand by clicking raise hand icon in your Zoom room, or type your question in the comment room for you who followed this lecture from YouTube. I'm pretty sure that you have so many great opportunity to discuss with such a great lecturer from Nottingham University, Malaysia.
Thank you. Well, thank you for commending me. Thank you.
Okay, dear student, anyone have a question?
I mean, the students are quite shy, you know. I don't know how the Indonesian students are, but I've seen those students on the field. Very excellent, yes.
Probably next after this pandemic, crazy pandemic era ended, we can have you here physically in our university.
Yeah, exactly. I mean, these are well, the biostimulant. I mean, they have just propped up from nowhere, you know, and some of these biostimulants might be working in a different area, and they want to try it on plants as well. And some of these biostimulants might be a product of certain industry, and just out of profit, you know, the objective of these companies, out of this profit, they want to try it on plants. How does it affect plants and soil? So actually, this soil, some of them are actually genuinely being released by companies like Bears and Crops. Some of them are very effective, and these microorganisms that increase the decomposition process. Okay, they increase the availability of some of these nutrients and the carbon that is present, the organic matter. So they help in the decomposition process. So that's how it increases the organic matter. And yeah, so we are still trying to analyze our data to see what the mechanism is. But we have seen more root growth in those treatments where the organic matter has been applied. Sorry, the bacteria has been applied. One of the bacteria is Bacillus, you know. So that's, yes, one of them. And there are other ones, I can't remember the names, but they do increase the root biomass is relatively higher than where there was no bacteria. So, yeah, so it has increased. So it also helps in breaking down the chemicals, the compounds that are being released by roots, you know, into the rhizosphere. So it has multi-purpose functions and something that needs to be validated. Yeah, we are into process of doing that. So that's one way how it does that. So increasing the decomposition. But certainly, again, I said earlier, increasing too much of decomposition, we lose too much of organic matter. And too much of decomposition means that the nutrients will be released faster than they are being uptaken by plants. So we need to be careful. So we need to know the soil that we are trying to apply the biostimulant and see how it functions. So the soil data is very, very important. Yes. So IoT should play a very important role, and we must have all the data, all the information about the soil I am cultivating, and that's to be provided by the government. So there must be a database where all the information is in your hands in a phone, where you can get down the temperature, you can predict the rainfall, and you can get the soil type. So that's something very important and will play a very important role in future as well. Yeah.
So probably the key as of the IoT is managing how to balance the input and the output of organic matter to the soil. Yes. Okay. Well, I've seen that someone asked question from YouTube, probably. The committee have shared the question earlier. Is there any question from the participant from YouTube? Okay. Okay. First question is from Akmal Iza. What is aqua crop model from FAO? It seems preferable to use to increase the efficiency of water use. Is it possible to use aqua crop model in Indonesia because some area here suffering drought and need better irrigation management?
Well, I would advise you to use that. And if you're especially suffering from drought, yes, go ahead, download the software. It's free of cost, free of charge. So get to know the aqua crop model. It's on the FAO website, and there are instructions for that. And you need to enter the data that you have. So read about the model and know the data that you need to collect on the crops that you want to work on, especially if you're in a drought-prone area. And read about the model and the data that you need to collect. Yes, you can use it in your area as well. And the model is free. Yeah, so please make use of it, learn about it. And in some places there are training being organized. So just look out for it. And the FAO organizes training as well. And there are some other organizations that do organize. There are so many models, not only crop. So you can attend those trainings. And you can do modeling in soil. You can do modeling in crops as well. But certainly you have to use a lot of data set, feed in the data set into the model, and then it will predict what will happen to your soil in the next 10 or 20 years based on the information that you have provided. Yes, you can do that, yes. Yes, please check the FAO website, contact them, and they do advertise about trainings. If not FAO, there are other organizations that do advertise for trainings. Attend it, and that will increase the quality of your work that you are doing. I mean, you can integrate modeling into your work, yeah. And certainly you will be able to solve problem in your area that you are referring to. Yes, certainly very useful. Yeah.
Thank you very much, Dr. Singh. So probably to use the model, we need to upscale the data that we have, and we need to choose which data can be used to this model or that models. Because Little Bird told me that garbage in, garbage out. So if we put the wrong data to the models, so the output is also wrong.
Absolutely, you're right. Yes, you're right. So certainly there are lots of models available, and you might probably try different of them and see which one gives you a good result. And absolutely, I agree with you. Yeah, that's true.
Okay, thank you very much. Any question from the student? Feel free to raise your hand by clicking raise hand icon in your Zoom room. Another question from YouTube probably. How long humidification of organic matter takes time? Averagely, we usually apply organic fertilizer a week prior to planting. Will the humus form during the growth of the plant?
Okay, yeah, I mean that's a tricky question because it all depends on the CN ratio. As I told you in one of the slides, it depends on the lignin and polyphenol content, and if the CN ratio is quite low, as we have in legumes, and assuming an agroforestry system, I think Professor Cho will agree with me that in agroforestry system we have Leucina. When you prune Leucina and incorporate it into the soil, so that fresh green leaf has a very low CN ratio. It has high N content, and that will decompose very faster within the crop cycle of maize or groundnut. Are you following? So within that cycle, 3 month cycle or 2 months cycle, that because the N content in Leucina is quite high. But if you incorporate oil palm residue, which has N content of 0.4 and a CN ratio of 100, that might take a year to decompose or humify. It's not Cho. Yeah. Exactly.
Okay.
Yeah.
Depends on the N content that you have, depends on the quality of the residue that you're applying. Yeah.
Yeah,
So,
that's right.
Thank you very much. I see that someone raised hand previously. Is there any question from the student who followed this lecture from Zoom? No one? Probably the last question from YouTube. Is there any question? Any other question? Why does lignin and polyphenol must be assayed on residue of the plant? Will they produce different quality of humus?
okay, why does lignin and polyphenol must be assayed? Okay, different quality of humus. Well, humus actually is the last, and when the lignin and the cellulose, when the microorganism acts on it, eventually end up into humus, which is mostly, humic acid and phthalic acid. And so the end product will be the same. It's just that it will take a longer duration to decompose because lignin, these are very hard materials, very difficult to decompose. So the end product will be similar, but the duration will be very long. Yeah.
Thank you very much.
Do you have anything to add, students?
Yeah.
Sure, do you have any answer about that question?
Well, about what is the question was related with the polyphenol and lignin, right?
Yes, yes.
Yeah. Well, actually, what is the purpose? What is the problem related with management? For me, if it is the residues, the plant residues has very low lignin and polyphenol, it will be fast decomposed, and then that one will be, of course, that is giving the nutrients availability quickly supplied to the plants. But of course, the amount will not be as much what the plants needed. Yeah, but then giving difference or diverse quality, litter quality, it really helps because we need, especially in the tropical area, we need not only for the nutrient supply. Nutrient supply is quite easy. Farmers will just add the fertilizer, that's it. But maintaining the soil organic matter, as Dr. Ajit mentioned, is very, very important. to maintain the, especially in the era of climate change, maintaining the water availability. That is the key of the achievement, if we maintain the soil organic matter. Now, especially if we are working in the drying area, in the NTT, for example, Nusa Tenggara Timur or Nusa Tenggara Barat, that's all are dry. And I think the soil organic sequestration of soil organic matter is very important. I fully agree with Dr. Ajit Singh. Yeah, I think I added to that for maintenance the soil fertility, not for adding the nutrients availability per se. Yeah.
Well, actually, the soil organic matter, actually, I mean, there are a lot of, it's not just one matter, one compound.
Exactly.
At a particular time, you have residues that are not well decomposed and that are partially decomposed, residues that are resistant to any decomposition, that's the humus.
Exactly.
So eventually, the end product is the humus. Now, humus is very complex compound.
Exactly.
It's different from the residue that you have added. Okay,
Yeah.
There's a lot of synthesis happening. Humus comes up with a lot of synthesis there are a lot of organisms that work on it to create this humus. Okay, so the functions are completely different from even the organic matter that you have applied. So there are lots of activities happening in this, but the end product, of course, is the humus, which cannot be is resistant to decomposition. Yeah,
exactly. Yeah,
and the rate will depend on the quality of the residue. That is, if it has more lignin and polyphenol, like wood, which has more lignin, wood will take a very long time to decompose, but it will, 2 years, 3 years, depending on the soil and moisture, it will decompose into humus, but will take a very long time.
Yeah.
Similarly, we have biochar that is becoming very popular. Prof, is it not biochar? You know, biochar is a pyrolyzed material. I mean, so that's also becoming quite popular. Yeah.
So, yeah, can I ask a question?
Yes.
Oh, sure. Pak Cahyo, please take your time.
So, yeah, welcome, Dr. Ajit Singh. So, nice to see you.
Nice to see you as well. Yes.
Yeah, hoping that in the future we can meet face to face then.
It's better than
okay. Just one question: is that ratio between stable and unstable sea organic matters? Yeah. For instance, the ratio between a stable and level of sea organic in the soil is true. Is that important to looking into in more detail rather than total sea as well? So from the FAO information means that it cannot detect whether it's the form of the organic sea itself, whether it's in stable or in the liable conditions. So due to these reasons, whether in the futures, is there any research is just most focus on the ratio between the different fraction of the soil sea is still important in the futures, rather than just have a look at in the total sea itself? Thank you.
Yes, thanks a lot, Frag. That's a very important and good question, because stability is important. If the carbon is not stable, then certainly it will be easily lost, is it not? So in terms of climate change, in the context of climate change, that's not very useful, because if you have a lot of carbon that is not stable and is highly labile, or it's easily dissolved away or washed away or taken along with rainwater, because anything that's unstable will easily be lost into the system. So that's very, very important said. And it will be no doubt very important to mention that, yes, this portion is, this much is stable and this much portion is unstable. But when we refer to climate change, we normally refer to the one that is stable, which is the organic matter, which is related to like cellulose, is stable. So the carbon in form of cellulose is more stable. Okay, then the carbon in form of proteins that are in part of protein, cellulose, lignin, and other compounds are more stable, and they must be decomposed to become nutrient and release CO2 that is unstable. CO2 is not stable because it can easily move out into the atmosphere and cause climate change. So I agree with that. There must be some distinction. What proportion is stable and what proportion is unstable. And that will have a significant impact on climate change, no doubt about that.
Okay. Thank you.
I agree with that. Yeah.
Okay, thank you very much, Dr. Singh, Pak Cahyo Bucho, and all the audiences. Unfortunately, we have a very limited time, so we should end the guest lecturing today. And we will see each other again at Friday to learn about nitrogen and phosphorus balance to secure crop nutrient uptake.
Okay, thanks a lot.
I thank you very much to Dr. Singh, to your time and your great presentation.
Thank you very much.
And also for all of the lecturers of Soil Science Department and all of the students who follow this lecturing both from Zoom and YouTube. I'm sure that we are achieving so many new knowledge and experience about managing and maintaining of soil organic matter. And before I close the program, I would like to request Dr. Singh's time for a while, probably 30 minutes for joining with the lecture staff to discuss about potential research collaboration between University of Brawijaya and the University of Nottingham, Malaysia.
Yes,
and for all of the audience, please leave the Zoom meeting. And finally, I'm Novalia Kusumarini, the moderator of today's program. Ask for leaving the meeting. Finally, wassalamualaikum warahmatullahi wabarakatuh. Good afternoon